Hi, everyone. Hello. Is anybody out there? So that's actually a really nice talk to follow. So my name is Kate Hartman, and I guess the things I'm going to speak to you about today live mostly on the body, or around the body, or near the body. And so just to follow up on what Kyle has been speaking about, I also am someone who shares tools, and that's something that I'm quite interested in. And specifically, I'm interested in technologies that live on the body and have to do with things that sort of occupy this context, and especially how bodies communicate with each other. So just an example of one tool that I share deals with the concept of wireless wearables, and so how bodies communicate. And so I have done lots of projects in this realm. For example, we see this one in the slide title. But I also am interested in how people think their own clothing should communicate. So this is an example of a type of circuit board that I helped design that is meant to incorporate radio transceivers into clothing. So it basically enables the ability to communicate between different garments. And so what's fun about this is that, like Kyle said, you never know what's going to come out. And so these are just some examples of different projects that people have created with this one particular piece of hardware. So one is a dance costume. It's called Spin, and it's a situation in which the dancers actually control the music with their own bodies. Another is an audio controller that's worn in performance called Dream Squawk. And another is a set of networked pajamas for people living in different continents so that their sleep patterns can be matched and communicated. So I'm particularly interested in inquisitive devices and devices that are curious. I'm particularly interested in devices that are able to ask questions and provoke interactions. So I guess before I go on, what might be helpful is if I tell you a little bit about myself. So I am an artist, a designer, and a technologist. I make hats sometimes. I also make technologies. I actually have a job. I'm an assistant professor at OCAD University in Toronto. And I have a lab there called the Social Body Lab. One other thing that I do is I direct a summer program in New York called ITP Camp, which I won't talk too much about today, but if you guys are interested, let me know. So I'm really interested in the physical, and more specifically dealing with hardware and tools and projects that are body-centric. And so I like thinking about the way in which the things that we wear can interface and affect the way that we relate to the world around us. And so I work with a large variety of tool sets, some which are a bit more unexpected than others. So I communicate through everything from radio transceivers to funnels and plastic tubing. And so my portfolio has kind of an unusual mix of stuff. I make things like this. So this is a glacier embracing suit, and I know you guys all have one at home. But it is made out of a heat-reflective material, and it's meant to serve as an interface between the human body and glacial ice, so that a person can actually lay down on a glacier and embrace it. And then I also approach interactions and relationships from a more technological perspective. So just to give you a sense, I can tell you a little bit about one of my other projects. And I'll show you a little video of that.
Hello there. Today's plants are abused, neglected, and misunderstood. Modern life and an increasingly technological and automated society leaves little room for our leafy green friend, the plant. Oh, poor little guy. An elite group of scientists have been hard at work conducting experiments to right this wrong and create a better life for our potted pals. Aha! Here's a bright idea. Quick, everyone, to the lab. Moisture probes inserted in the soil transfer conductivity information via transitorized circuitry to a series of microprocessors which send serial information via gigahertz radio waves to mainframe servers and connect to a global network of bidirectional audio communication units. Now when a plant needs light or water, a ring-a-ding-ding. It gets on the line and makes a telephone call.
Hello, this is Cuban oregano. I am in need of watering. Could you please water me until my soil is quite soft?
The new system is botanicals and lets plants call for human help. These friendly flora can't be neglected, but you won't only hear from them when they're glum. Botanicals plants mind their P's and Q's, politely phoning in their thanks whenever caring hands have helped them out. Our lives are getting better. Thanks, scientists. You're making it a botanicals world. Botanicals. The plants have your number.
So that gives you an idea of what it's like when I approach things from a more technological perspective. But I really do like devices that challenge our expectations. And so just to give you a little sense of how I work, this is a project that started out, when I was a graduate student, and we wanted to bring plants into the lounge of our graduate program and make sure they stayed alive. And so we devised this network telephone system where when the plant would need water, it would call the sort of public phone and say something like this.
Hi, this is the Ivy. I'm desperately in need of a drink. Do you think you could find it in your heart to maybe water me a little? Thanks.
And then when you went and watered it kindly, it would call back and let you know that it appreciated it.
Ooh, thank you for watering me. That felt like a fresh spring rain.
So originally, we developed this project for the telephone because we really liked the communicative nature of the human voice. But eventually, we switched over to Twitter to make it accessible to a larger audience. And so the interesting side effect of this was that my plant ended up with over 3,000 followers, which was more than I have. So it's kind of an interesting moment. But one of the driving forces of this project over the next few years was really to put it in the hands of other people so that they could use it as well. So we went through the process of publishing a DIY tutorial online, to making a first basic kit, to eventually designing our own in a custom-shaped circuit board, to actually producing these in some quantity and selling them out of one of my collaborators' living rooms, and going through that whole process, and then eventually partnering up with SparkFun Electronics and selling kits through them, which was really interesting. And actually, one of the most interesting turns for me was that this work ended up in the Talk to Me show in the Museum of Modern Art in New York. And so what went from being this really scrappy project is suddenly on display in this case of all of this open source hardware in the MoMA. And so I think this asks a lot of interesting questions in terms of these kind of renegade ground-up tools that then get exhibited as art or design objects. And what does it mean for these things to exist in this context? Because they are exhibited as objects, and then that's really exciting because it raises the awareness of them, but it also strips them of the interaction that's intended with them. So I think this is a really interesting thing to watch with a lot of these tools and where they come from and where they end up. So in terms of what I do, one particular object that keeps popping up quite frequently is this. So can you guys do me a favor? Has anyone seen this before? If you can just raise your hand. Has anyone used one? OK, so some of you, but not all. So this thing is called an Arduino. And it is an open source hardware and software platform for prototyping electronic projects. And with all the work that I do in different sectors, it's actually quite interesting because it just keeps popping up again and again. And yeah, so the guys who made it describe it as both hardware, software, and a community, which I think is a really important aspect of it. I describe it to the people who I use it with as a canvas. So it's basically a really stripped-down computer. It's a microcontroller. It has blank slots for inputs and outputs, and that's pretty exciting. So I like to think about it as an invitation to consider how to interact with computers. And for me, this goes back to something that's called physical computing. And this book first came out, I think, in 2002, 2003. And things have changed a bit since then. But one thing I liked in particular in this book when it was published was that it had this diagram. And so the authors define this as how the computer sees us. And so when a computer looks at us, it knows that we have some sort of vision because it offers us a visual display, and it expects us to have listening capabilities, and it knows we have some ability to press buttons. But that's pretty much it. And now, since this book was published, things have changed a great deal. Obviously, we have a multitude of devices that take a variety of inputs, but I think that's still a really interesting concept for us to think about, is how do we want computers to see us? And how do we want them to have an awareness of our desires and our needs and our physicality and what we're expressing? So within my work, I deal a lot with just taking simple electronic components and seeing what's possible with them. And so I work as an assistant professor at OCAD University in Toronto, in Canada. And I'm part of the Digital Futures program there. And so what I deal with a lot in my teaching is sort of this idea of making as a curious act. So making as a method for exploring and asking questions and sort of following through ideas. And so we really go through this process of taking those parts and seeing how they can work into different interaction scenarios and considering, how this relates to our own physicality and expression as humans. And so because a lot of the things that I do are very body-centric, I always like to talk about the reason why bodies matter. And the reason's really simple. It's just that everybody's got one. So everybody in the audience has a body, and it acts as our primary interface for the world. They're all very different, and we use them in different ways, but they are our interface. And so when you're working to create and design different interactions, starting from the body and moving out from there is actually a really powerful space to work within, because it's quite upfront and it's quite personal. And so that's why I like working in that space. And so the university that I work at is an art and design school, and so I work with these very creative minds. And I find in life that I kind of switch back and forth between either teaching technologists how to be creative or teaching creative people how to work with technology. And so right now, I'm mostly dealing with creative people. And so they have all these different notions of what to do with the body. So this is my student, Alex, who just created this kind of interesting exoskeleton for herself for her final project. And she really wanted to consider how, how one part of her body could make the other part of her body move. And so what I do is I take these students who are industrial designers or deal with textiles or jewelry making, or they're in sculpture or different types of electronic arts, and I introduce them to new technologies, and we work from their concept to completion in terms of how they can incorporate technology into the things that they make. And so dealing with simple circuits like a simple force-sensing resistor and imagining what the possibilities for that are. So this is an example of my student, Rachel, who does a lot with felting. And so she's working with felting electronics into these masks that are used for performance. And so this is one that's called the blush mask. And when you grasp the cheeks, it actually can blush for you. And there's another one that blinks and that sort of thing. So because at the moment I'm positioned within academia, I think a lot about the relationship between academia and the maker hacker scene and movement, and how they're kind of feeding each other at the moment. Because the way I teach right now is very different than the way I would have taught 20 years ago, because of the resources that are available. And I'm actually really interested in the evolution of education and how it's affected by that. So an example, that's interesting to think about where students get their influence. This is my student. My student Hillary was thinking about this belt that she wanted to make. She really wanted to make this belt. And this isn't her work, but this was an inspiration for her, these U-lock holders. So I live in Toronto, and everybody bicycles there. And so she really wanted this belt that could hold her U-lock and could hold her wallet and her phone, but was beautiful. And she couldn't find anything like it. And so she took inspiration from this project. And then she also took inspiration from Diana Eng's laser lace project, where she uses a simple laser cutter to bring beauty to a basic T-shirt. And so Hillary went ahead and combined these two things to create something of her own. And so she very much was inspired by the constraints of the production process And so she created a design and a pattern that fit a typical sized bed for a laser cutter. And then from there, she went through and did a series of tests. And one thing that I found interesting about her project was she ended up moving beyond the university in her production process. So we have rapid prototyping facilities at the school. We have laser cutters and that sort of thing, but it's operated as a service bureau, and she really wanted to learn how to use the tools herself. And so she ended up doing a full scan of all the laser cutters available in Toronto and ended up at Site 3, which is one of our local maker spaces. And from there, she got tapped into a whole different community that taught her how to use these tools in a much different way. So she went through and laser cut the belt and tried all these different methods in terms of assembling it with an industrial sewing machine, and then went through a whole series of iterations. And this is something that we talk about in my classes a lot. It's just how to iterate and how to develop a concept to something that actually works. And because I teach a lot of wearable technology, the motto in the class is very often, wear early and often. So this was the resulting project. And we usually have an end-of-semester show where we exhibit different wearable technology works. And the thing that becomes interesting about it is that it's very participatory. And so a lot of these works end up with a wear me or touch me sign because they are meant to be interacted with and they are meant to live in the space of the body. So the other thing that I do at OCAD is I am the director of the Social Body Lab. But before I get into talking about what we do, I'd just like to take a moment to think about the superheroes out there. So one project that we made is actually called the Superhero Communicator Cuffs. And so the thing about these cuffs is that they actually enable you to signal your superhero with some really simple materials. So if you are in distress and you need to get in touch with your other superhero partner, you can actually just take these cuffs and put them on and go like this, and it sends a signal to your partner. And so where this project lies is in a set of DIY tutorials that the lab publishes. And we are really interested in engaging people in the process of creating technology and thinking about the place in which technology sits in their lives. And so it's not so much about whether or not technology will eventually inhabit people's clothing. It's about how will it and why. So we published this whole set of tutorials using radio transceivers and conductive fabric and thread to ask people how they would like to do this type of communication. So we're really focused on the social implications of wearable technology. We work a lot with different materials. So we work with conductive materials of different sorts that are a bit non-traditional. So we use conductive textiles, threads, and fabrics, and yarns, and that sort of thing to create circuitry that's soft and pliable. And this is interesting to us because it makes it attractive to a different audience than we would otherwise assume might be interested in this sort of thing. And just really thinking about this process of prototyping and showing people how to prototype and getting from kind of a raw circuit to something that's complete. And yeah, so it often goes down to the material level, because what's kind of exciting about some of this stuff is we're using the simplest possible technology. And in this instance, we're creating a switch with 2 pieces of conductive fabric. And that's kind of exciting because you can, when that's implemented in a certain way, you can create a switch on any part of the body. And so I've run a lot of different workshops, using these materials in this way. And so, when you ask people to go ahead and create a social interaction with a piece of conductive fabric, it gets quite interesting. And so these are just some examples of, one workshop that I was teaching where people were asked to create social prosthetics, and they came up with all these different designs. So within the context of the lab, I have a lot of different people working there, really interesting set of research assistants. Some come from the arts, some come from design, some come from engineering, and they all really approach things from a different manner. And in addition to sort of more outward-facing projects, we also are involved in a lot of different research projects. So this is an example of some wearable technology in early prototype for thinking about posture and mobility in the workplace, specifically for people who sit at computers all day. So encouraging them to improve their posture and then also to move their wrists a bit more. We also look at different materials, so different conductive inks and conductive paints to think about what their potential is in a prototyping and interactive scenario. I also have a residency going, sort of a postgraduate residency. So currently in residence, I have this woman named Aldous. And she is working with, she's a kind of a master weaver. And so she's working with weaving fiber optics into cloth and turning it into a dynamic display. And so she's very interested in how can technology be elegantly incorporated into clothing. So yeah, so she's really going through this process of literally weaving the technology into the cloth. And she is currently working on a project. This is a test, and she's working with these very thin fiber optics where she's creating a pleated skirt where the interior of the pleats are able to be addressed and lit in different ways. And then the exterior is just plain cotton fabric. But it's all just a single piece because it's been done from the weaving level. So one of the last activities I'll talk about from the lab is we have this event called the Toronto Wearables Meetup. And so this is really thinking about how things that happen within the realm of wearable technology sit at the intersection of a lot of different fields. And so this is a monthly lecture series that we run where people come out from all different communities across the city. So we have academics, we have students and professors and that sort of thing from a lot of the different universities. But then we also have people coming in from fashion, from industrial design, engineers, programmers, that sort of thing, people from the startup culture. And it's quite interesting to get them all in the room together, give them a topic to think about and kind of hear what comes out. So yeah, and really nice moments happen. Like this was one evening when we had a discussion between one person who was working in thought-controlled computing and someone else who's working with techno-textiles. So I think moving forward, really considering interdisciplinarity and the variety of skill sets needed to pursue projects in this arena is quite fruitful. So background to this thing. I guess in looking at this, this is just a really, really simple tool. But the question to ask is, why is this interesting? Why is this kind of rich territory? And why might it be important to us? And I guess because I've been teaching in this realm in a lot of different areas, either through university classes on the undergraduate or graduate level, or even workshops and going to hackerspaces, that sort of thing, I've got a couple of ideas of why I think it's important. One is this idea of fear and power. So I'm really interested in the human-technology power dynamic. And I think there's a lot happening in technology very quickly. That much is obvious. But I think there are some people that feel a bit overwhelmed by that and a bit intimidated. And that bugs me. I really think that technology is just another set of tools that people can use and design as they like. And so that's why I sort of enjoy working with these different communities. And it's quite interesting working within the art and design context because I have these students who are actually highly technical, but they don't quite know it because it's older technology. And so I get emails like this. So this is a student who had just joined my class a couple of weeks prior, and she sent me this email that said, "Hi, Kate. I wanted to let you know that I am dropping the Wearable Technology 1 course. I think the content of the course is extremely interesting, but I have been struggling to come to terms with working with technology in my work, and I have just come to realize that I don't think the way technology thinks. This is a difficult realization to have, and I'm still open to learning about technology. I'm just not sure that I can do it at this time." So this is interesting to me, because this is one of my, it's apparent early on that this was going to be one of my best students, and here she was dropping my class because she was intimidated by the technology. And so she ended up sticking around and becoming one of the strongest students in the class and producing some really brilliant work, actually some that I've shown already in this presentation. So to me, it's essential that people have a sense of agency in the tools that they use. And anything that can be done to open up any existing or emerging technologies to allow people to participate in it some way or to have a say in it in some way is really fruitful. The other thing that I think about is porosity of these technologies. And so how, what they can soak up or what they can, if they can be infiltrated or accessed in any way. And so the technologies that are more pliable and malleable are the ones that are more interesting to me. Whether it be through their source code, their design files, or their circuit diagrams, just giving people some ability to access it is really important. And yeah, so accessibility in general, just anything that's affordable and accessible and that you don't have to dig through the entirety of the internet to understand how it works, can be really fruitful and really inviting to help someone to get involved. One of the last concepts is ownership. And within the realm of a university, this becomes an interesting question because my students get really concerned about copying other people's code. And we end up having a lot of conversations about attribution and open source culture and what it means to work off of and beyond the work that somebody else has done and how that can be an actually really beneficial and incremental process. And finally, I think with a lot of these tools, there's opportunity for education and expression. So very often when I talk about my work or my students' work, the first question is, well, what does it do? And I think a utilitarian approach is very important, but I think creativity is the ultimate tool for exploration, and oftentimes we have to make before we understand what it is. But I think really fruitful things can come through that. So finally, I really enjoy working with these tools and thinking about what can come out of it. This is an example of a set of my students, all starting out with the same set of tools and producing this really diverse range of projects. So everything from a belly dancer's costume to a helmet for miners to detect noxious gases and blows to the head. There's also a hockey helmet in there. There's an earthquake that tremors, an earthquake skirt that tremors every time there's an earthquake in the world. And there's a piece of stock market lingerie which reads off stock quotes as it gets unhooked. So thanks.